Okay, so today's topic is completing the square. Before we kind of get into the nitty-gritty details, here's my review. We've been working with functions, and the main two functions we have are linear and quadratic. We're now getting ready to go to the point where we're going to learn about more types of functions. So you guys, lucky you, get to do absolute values and reciprocal functions later in this course, and then a whole bunch more next year. Yay!
You only need 20 to graduate.
Yep.
Alright.
Just making sure. You'll be fine. Okay.
Yeah.
So here's some pictures of some of the functions we're going to do. We've already done linear and quadratic. One of the questions on your new assignments is actually about how to do an absolute value. Absolute values look like quadratics, only they meet as a V rather than as a U. And if you happen to get to the absolute value one, I'll show you how to graph it before our lesson on Thursday if you want.
You gotta push that catalog.
Yeah, I'll show people one at a time if they need.
And
Okay?
the actual.
Don't worry about it. When you need it, I'll show you. Okay. Okay. Here's some review. Here's quadratics. Quadratics have a vertex, and the other thing I've been kind of hinting at here is that there's always that leading coefficient, that a value right in front, right? That leading coefficient really dictates the shape of the graph. It tells you whether it's up or down, how steep the graph happens to be. When you guys learned about linear functions last year, a good old y equals mx plus b, you guys should have learned that this value right here is the slope of the graph. It is, but I really prefer the word leading coefficient because that applies to all graphs. When we eventually do that graph, or that graph, or that graph, all graphs, regardless of what type they have, they all can have a leading coefficient in front of them. And that leading coefficient does different things to different graphs. But anyways, that concept makes sense? So it controls shape, essentially. So let's try an exercise here. Tell me the values of x here if f of x equals 3 or 8. This is really back to the algebra unit, more so than the what we're working on right now. What does it mean here if I tell you f of x equals 3?
Like 3 equals the equation.
Yeah, 3 equals the equation.
How would you quadratic formula?
Yeah, so to solve this, you have some options. Option 1, quadratic formula, minus 3 from both sides. So I'm just going to leave it here, though. In the interest of time, could I just say use the formula? That would work. Is that right?
Yeah. Oh, that's how
You're good. However, another idea would be to do this. Take your graphing calculator. Type in the equation. Negative 2x squared minus 5x plus 3. Type in the second equation at 3 and see where they cross. See how they cross twice? If you were to intersect, wouldn't that also give you the answer? So in a way, you now have two tools at your disposal. You could do what you did in the algebra unit and factor and use quadratic formulas to solve, or you could intersect on your calculator. Both kind of run the same way. And if I ask you where this will equal 8, I won't actually solve this just to save some time, but where does this eventually equal 8? The answer is it doesn't, right? Which means that if you use the quadratic formula, you should get a negative discriminant. So, but I don't need to go through that. You guys remember how to do that stuff?
Mm-hmm.
Okay, so let's move on. Okay, so the point I wanted to make leading into this, though, is that that vertex is such a critical point. That vertex is such a critical point because really, depending on where that vertex is, tells you whether or not you get your 1, 2, or 0 solutions. Right here, the vertex was below, or sorry, the line was below the vertex, so you have 2 answers, right? Here, the line you're looking for is above the vertex, you have no answers. So it is possible to find that vertex using the minimum or maximum values in your calculator. But today, what really separates dash 1 from dash 2 is I need you guys to know how to do some other algebra in order to find that vertex. Hence the whole, this really sucks. So for dash 2 kids, if they want to find the vertex, we just say, look, use your calculator, put the little arrow things here, find that point there, it's out, you're good to go. Right? But I need you guys to be able to find the vertex in other ways. So here are kind of like the 3 main ways of writing quadratics. And I was kind of hinting at this as we were doing our examples beforehand. One way you can write a quadratic is in like a factored form. For example, 2 bracket x minus 1, x plus 2. That's a quadratic. What does this 2 tell you about the graph? Happy face graph. You know what I mean? Right? It's going to be upright. That 2 means it's upright. If it was a negative, frowny face. What about the x minus 1, x plus 2? What is that useful for? What does it tell you? Your intercepts, yeah. This tells you your x-intercepts. Right? For this example right here, my x-intercepts would have been a 1 and negative 2. So that's actually kind of a useful format if you know how to do some algebra. If you can factor or FOIL, you can find intercepts using a factored form. Another way of writing it is in standard form. For example, 3x squared plus 7x minus 12. What's standard form useful for? Good, your y-intercept. Because your y-intercept is your constant term, negative 12. Vertex form would be like, I don't know, negative 2x minus 1 all squared plus 7. It tells you your vertex. Your vertex would be 1 and 7. So each kind of different format of writing a quadratic is equivalent to each other, but they all have a different purpose. One will give you a y-intercept, one will give you an x-intercept, one will give you a vertex. All of these things you can find using a graphing calculator for sure. But again, what separates dash 1 from dash 2 is that you shouldn't need a graphing calculator, if that makes sense. You should be able to find it without a graphing calculator. So hence today is going to be fun. Okay, so let's try some examples here. What format is this in right now? A factored form, a vertex form, or a standard form?
Vertex.
So based on this, I don't even need a graphing calculator. You guys should be able to tell me the vertex is at negative 3, negative 5. Right, you don't even need a graphing calculator. This, you have to flip. So negative 3, negative 5. There, this is your vertex. You have it right off the bat.
Why is only one flip?
It has to do with being inside this parentheses as opposed to this one being outside the parentheses. It's kind of the short answer. If you want, I can give you a longer answer later. Essentially, what's important for you guys right now is just know that. That's the rule. This right here, flip. That one you don't. Now, let's say, though, that you wanted to know the y-intercept. Does this format tell you the y-intercept? No, but standard form would. So this is kind of what, Jake, when I was doing that example earlier, I was kind of flying through here. What you could do is just write it out with itself next to it twice. You could FOIL this thing to death and make it 2x squared plus 6x plus 9. Double it all. So now I have it in standard form. What's standard form good for? Not a lot, honestly. Let's tell you the y-intercept. What's our y-intercept? 15. There you go. So you don't actually need your graphing calculator if you know what you're doing algebraically. You should be able to find out almost every single property by hand. No, you can see why the split between dash 1 and dash 2 is very, very evident, right? If you don't have solid algebra skills, you'd have no hope on this, right? Like you have to be excellent in algebra to be able to do this. So, let's talk about the next one here. This is in like a factored format. So what can it tell you? Well, I know that it's upside down because of the negative sign. And I know where the intercepts are. One of them's at 1, and the other x-intercept's at negative 2. But again, let's say I want more than that. Let's say I want to know what the x-intercept is. Sorry, what the y-intercept is. FOIL it. Okay. Take negative 2 and make it x squared minus x plus 2x minus 2. There. Now it's in standard form. And if I want to know the y-intercept, and there's my y-intercept. Does that make sense? So, again, not something that you normally would want to do, because it's algebra for the sake of algebra, but hopefully you can see that if I really wanted to confirm, maybe while you're finishing, I'll just confirm here. If I gave you the equation -2 x minus 1, and another one with x plus 2, and we graphed it, look, here's an x-intercept at -2. I could have predicted that because of the plus 2. Here's an x-intercept at 1. I could have predicted that because of the plus 1, or minus 1. It's upside down. I could have predicted that because of the minus 2. And the y-intercept looks like it's at 4. Now, this equation right here didn't tell me that it was 4, but a little bit of foiling told me that it was 4. Does that make sense? Let's try some more. This is in standard form. If I want to put it into a factored form, well, this is what we've been doing this earlier algebra unit, right? To put it back into a factored form, you'd go x. Actually, I don't think we can factor that one, can you? How about we do that and then make it x plus 3, x plus 7. All right, make that a plus sign. I must have a typo there. Thank you for the slip up there, I appreciate it. If it were factorable, then hopefully you guys would agree the y-intercept is now plus 21, since I obviously screwed that up. If I asked you for the x-intercepts, could you tell me the x-intercepts? There you go, easy, right? So once you get a little better at this, you don't actually need a graphing calculator. You can do it all by hand. Now, in this course here, I'll still let you guys use your graphing calculator. And you still get it in 30-1. But if you eventually get to the point where you start taking calculus, you have to do very similar skills to this. And if you go to university, they probably won't let you have a graphing calculator. So you have to know how you have to have these skills. So even though most of this you guys can get around with your graphing calculator, if I can give you some advice, don't cheat the easy way out and just always go to your graphing calculator. If I ask you to do it algebraically, try it algebraically, and then check in your graphing calculator. Because if you shortchange yourself on the algebra skills you need, I promise you it will catch up to you eventually when someone says you can't have a graphing calculator. Okay? But for right now, when you do have a graphing calculator, try it both ways. So for this one right here, if I asked you to find me the x-intercepts, you could find me the x-intercepts by just going to your graphing calculator and finding them, right? But another option would be you should be able to factor, right? Do you guys remember how to factor this sort of thing? It's been a while. We need numbers that add to give 11, times to give 24. You guys remember doing this in our first unit? I know it's been a while. Skills probably aren't quite as fast as what I was just flying through there, but you guys recall doing this and remember how to do the steps? If you had to find the x-intercepts, and you just absolutely had to, use your graphing calculator. I'll leave this off to the side. Take your equation and go -2x squared plus 11x minus 12. Go to your table of values. Hey, look, I found an x-intercept. One's at 4. Right? It doesn't take you very long in your graphing calculator, right? The only reason you're not seeing the other one is that it's a fractional value, right? But if you knew how to do second calculate a 0, I bet you could find that one too, right? But the advice I'd give you, practice doing some of these by hand as well, because at some point, if you go far enough in math, you won't get a graphing calculator, you'll have to do it by hand. Okay? So now I know my y-intercept, and I know my x-intercepts. So far, so good?
Guess I'm not gonna be a doctor. Just kidding.
Okay, here's the hardest part. What if you want to find the vertex? Well, putting something into vertex form is very challenging. To find a vertex on the calculator, all you do is you find a minimum or a maximum, right? If you have a calculator, it's very simple to do. But if you don't have your calculator, and I want you to put it into vertex form, we need a way. So what I'm going to show you now is what's called completing the square. And this is what particularly sucks. So whenever you want to go into vertex form, there are a whole bunch of steps that we have to go through. So the best way I found to teach this is just to do a bunch of examples. And maybe the first one won't make a lot of sense. But after I do like 2 or 3, hopefully I can help fill in the blanks. So I'm going to come back to this slide here and work through all the steps that I did. But maybe just follow along. I'm going to show you how to turn this into vertex form. The first thing I'm going to do is I'm going to take my leading coefficient, if I have one. Well, I always have one, right? But if it's 1, I'm going to factor it out of the first 2 terms. But since it's a 1 right here, I'm not going to bother factoring. So I'm going to kind of skip that. The second thing I'm going to do is I'm going to take the middle term, and I'm going to look at the coefficient. I'm going to cut it in half. So what's half of 10? 5. Okay. I'm then going to square that number. 5 squared is 25. And I'm going to do this. I'm going to say x squared plus 10x, and I'm going to add 25. I'll explain why later, I promise. Okay, just go with it for now. Can I just randomly add 25 out of nowhere? That's not really fair, is it? So what I'm going to have to do then is, although I added 25, I'm now going to subtract 25.
What about the 21?
And I'm going to keep subtracting the 21. Okay. Essentially what I'm doing here is this term goes here, this term goes here, this term goes way back there, and in the middle right here, I'm going to add and subtract 2 consecutive numbers the exact same as each other. And it may at first seem like there's no real rhyme or reason for it. I promise. We'll get there. Okay. But would you guys agree at least that adding 25 and subtracting 25 is essentially canceling each other, right? Okay. But I'm not gonna highlight it in that sort of orientation. I'm gonna highlight it more like this. All of this is gonna go together, and these 2 are gonna go together. The reason why this works here is that this is something factorable. What factors to add to give 10 and times to give 25? What adds to give 10 and times to give 25? 5 and 5. Which means you could write it like this. X plus 5 with x plus 5. However, I guarantee you if you do it properly, this will always work out this way. The numbers that add to give these numbers will always be the same number twice. So rather than writing it out 5 and 5, you could actually write it out as x plus 5 squared. Your last 2 numbers, then, I've kind of ignored those for a little while. You put those together as well. So minus 25 minus 21 gives you minus 46. There. We now have our equation, and it's written in vertex form. So if we want to know the vertex of this thing, the vertex would be at -5 and -46. And we've now found that algebraically. Again, if you just had to have the answer and you didn't care about, working on your math skills, all you wanted to do is just pass the course. Here's the graph when I typed it in. All right. I have to change the window. Let's go back to negative, I don't know.
-50.
Yeah, I'm going to make this go down to -50. Now that I know that it gets as low as -46, right? And hopefully you can see that, yeah, right above there, if I use my calculator, that'll be -5, -46. But if you know how to complete a square, it saves you a lot of time. So let me talk through why this worked then. Okay. The key, the linchpin to this whole thing was the adding and subtracting of a certain number. The question is, what number do you add and subtract? Because, I added and subtracted 25. What if I did 19 or 42? Right? So the rationale is, it has to be this number right here, cut in half and squared. Whatever the middle term is, cut it in half and square it. If you do that, you will always create a trinomial right here which is two things that are the same as each other. I promise. Because what you're really looking for is a number that adds to give 10, therefore it has to be half of it. But a number that times is to give 25, which is where the squared part comes in. So let me read through the steps here. Yeah, Darren.
What if you can't factor out the leading coefficient?
There's always a way, it just may involve fractions in a sec, which we'll get to. It's always possible. I'll show you. Okay, so factor out the leading coefficient if necessary. What you're essentially doing is creating a perfect square trinomial by adding and subtracting accordingly. So here's the rule. Add and subtract whenever half of b is all squared. The middle number, cut it in half, square it. You can then write the perfect square trinomial like this, and then combine like terms on the very, very end to create your vertex one. So this doesn't maybe make as much sense until you do a few more examples. So let me try another one. First question, do we have a leading coefficient we have to deal with?
No.
I mean, it's 1, so there is a leading coefficient, but no, we're making it simple to start. So on to the second step. We need half of the middle term. Negative 2 technically. Square it for 4. But it makes a difference. So what we're going to do is we're going to rewrite this equation, only I'm going to put a big gap in the middle. And in that gap, I'm going to add and subtract the special magic numbers, which were 4, but then over here I got a minus 4. So what I've written in black here, it's kind of silly to do so, right? Because plus 4 and minus 4 really does cancel. But I'm doing this to try to separate this into two categories. Right here, I'm going to factor, and right here, I'm going to create like terms. So the like terms is really easy, it's minus 50. Problem solved. Over here, I'm going to factor this bit. What numbers add to give minus 4 times to give plus 4? Twice though, right? Technically it's x minus 2 and another x minus 2. But here's why I was kind of pointing out during your mistake here. Don't forget that negative sign, because it will matter when you're done, because it'll be x minus 2 squared, which is vastly different than x plus 2 squared. So don't forget that this negative sign still needs to be accounted for. There, we're done. It's actually not that bad at first. Where's your vertex? Your vertex is at 2. And minus 50. Based on that vertex, you can find a whole bunch of properties without knowing your graph. You don't even need a graphing calculator. I know now that the axis of symmetry is x equals 2. That's your axis of symmetry. If I were to ask you for your range is y is greater than or equal to negative 15. I don't even need to look at the graph. I can know those properties just based on my algebra skills. You guys can see though why this is the big difference between dash 1 and 2, right? This is where they kind of stopped and where we're going to keep going. Did that second example make a little bit of sense still? Okay, let's try another one. Okay, here, there's a bit of a change. Now there's a leading coefficient. That buggers things up. This 2 right here needs to be able to go, like when we're done, we need to have a leading coefficient there. It needs to be on the outside of whatever gets factored. So our leading coefficient of 2 needs to be foiled, like be factored out. But it needs to be partially factored. We only factor the first 2 terms. The last term just kind of sits off to the side. So I'm going to write it again like this. 2x squared plus 8x. And I'm going to throw the minus 3 way the heck over there. Because I'm not going to try to factor the 2 out of the 3. And we're only factoring the 2, not the x. So only factor the raw number itself. So I'm going to factor out a 2, and it'll leave you with x squared plus 4x. So far, so good? Okay. We now need to add and subtract a number that is like our magic perfect square number. So half of positive 4 is 2. Square 2, it's 4. So far, so good? Here's what I'm going to do, though. I'm going to add 4 right here. Because you see how this guy right here is going to be factored at some point? I'm going to minus 4 on the outside. times by 2. This is the hardest part. Okay. So here, we just randomly added a 4. Would you guys agree that right here, we've decided to add a 4 right here? But we didn't technically add 4. We added 4 times by this 2 out front. See that? This 4 right here is being impacted by that 2. So therefore, when I subtract that 4, it also has to get times by 2. This is the step that if kids get lost on, it's the step right here.
Can you take the plus 4 out of the brackets?
But we want it in the brackets because this thing right here is factorable into x plus 2 squared. Does that make sense? So although you're right, Naomi, you could bring it on the outside. We don't want it on the outside because all of this stuff right here so beautifully turns into something like that. Wow. Depends on your opinion. They're beautiful. So you still have a 2 sitting right here. On the outside here, then you got to combine your like terms. This is essentially minus 8. Minus 3 more, so it's minus 11. Now it's in vertex form. I know my vertex is at negative 2, negative 11. So, quick recap of how we pulled that off. I'm going to just erase it here. Okay. So if you can get to this point here where you factor out the 2 out of the first 2 terms, Naomi asked a great question. Do you have to put the number, like say here and here? You could, but do you see how that won't help? We want to put one of the numbers right here so that all of this becomes something squared. And therefore, to compensate, we have to subtract that number on the outside. Half of 4 is 2. Square 2, it's 4. But when you subtract 4, you have to times by the 2 that's out. Because this 2 essentially times by that 4, so you actually have to add 8 and subtract 8. This guy right here is hopefully very straightforward. You need numbers that add for 4 times for 4. It's 2 both times. And then all of this mess out here, you just have to combine the like terms. 4 and 2 is 8. Minus 8 minus 3 is minus 8. Is that good? Okay, let's try this one. This is the worst one of all. I'm gonna hate this. It's not the negative that's bad. It's the fact that it doesn't factor nicely. Do all numbers have to be nice whole numbers? No. It's nice if they are, but they don't have to be. Okay. Let me lead this off with a couple of thoughts here. I'm going to make you do this like once per test, just so you're aware. Like this is not a regular thing. You should know how to do it, but this requires like some of the most serious algebra chops you can have. Because like you have to be able to deal with fractions efficiently. So first step, I like to just rewrite it with the minus 1 thrown way off to the side. Because I need some space to work with. Then I have to factor out my first term, which is the minus 3. So when I factor out the minus 3, here's what I'm left with. See how that happened? I can factor the minus 3 off of the x squared, no problem. It's easy, just pull it off, right? But since 7 does not actually divide by 3, you have to write it as 7 over 3. Hopefully you can visualize. See how this minus 3 right here would then cancel this minus 3 right here? Getting you back to the 7 that you want.
And then you divide that in square.
Okay, so at this point here, I do a little aside because I need some room to write this out. So we need to take 7 over minus 3, and we need to cut it in half. Okay, now you can go to your calculator and try doing stuff there. Only, if I show you this trick, this is actually, this will save you some time. Cut it in half is that. What is 1 over 2 cut in half? It's 1 over 4. What's 1 over 5 cut in half? 1 over 10. All you have to do is take the bottom of your fraction and just make it twice as big. Okay? So that is your number that was cut in half, but you still have to square it.
1.36.
No, go with fractions though. If you get into decimals, I mean, some of you guys in my physics class will already recognize this. If you get into decimals, that's a horrible place to go because you'll never know how to round it.
49 over 36.
Yeah, this is better. 49 over 36. Square, not square root, square. Okay. So I know it was kind of ugly, but it's actually not bad. Take the middle number as your fraction, make the bottom twice as big. So 7 over 3 becomes 7 over 6, well, minus 6. Then when you square it, 7 becomes 49, minus 6 becomes 36. So I'm now ready for my next step here. I'll write this in a new color here. I'm now going to add 49 over 36, right there. And on the outside, I'm going to subtract 49 over 36 times by negative 3. Still subtract 1. Okay. For the outside stuff there, I'm just going to use my calculator and go like, say, minus 49 over 36 times by minus 3, subtract 1, and then maybe for my last step, you guys know how to turn it back into a fraction? You guys know how to do that? Math, fraction, turn something into a fraction. Long story short, all of this mess over here appears to be 37 over 12, which is 3.083 repeating. So for all that mess that's over here, just use your calculator. I know we can do that by hand, but use your calculator.
We can do that.
Why are you using 49 over 36?
Because 49 over 36 was half of this number squared. You know how I put that number right here?
Yeah,
I have to subtract it there.
I thought I made a mistake for a second. So,
Okay. The only thing I'm missing now is this ugly fractional thing right here. It should be able to be factored. Here's the downside. Who knows how to factor fraction stuff? That's horrible, right? But I can help you out with this. Okay. What this number right here is going to be, you know how when you cut this number in half, that's what it'll be. It'll be minus 7 over 6x. Or sorry, just minus 7 over 6. Okay, well, let me explain why. You're looking for numbers that times to give 49 over 36. Well, 7 times 7 will give you the 49. 6 times 6 will give you the 36, right? We also need two numbers that add to give 7 over 3. Well, 7 over 6 plus another 7 over 6 is actually a 7 over 3. Because really, 7 over 6 plus 7 over 6 is 14 over 6, which then reduces back to 7 over 3. So although the fractions are intimidating, what you guys need to know is that when you do this little off to the side thing, whatever this guy right here is, that's what goes there. So I finally have my vertex. My vertex is at 7 over 6, 37 over 12. So if we were to graph this guy, the negative 3, well, that still shows up right here, right? The negative 3 makes the graph go upside down. The vertex of 7 over 6 and 30 is 7 over 12. If you were to use your calculator, there, it gives us those values. I feel fairly confident in guessing that 7 over 6 is probably 1.166 repeating. And that 3.083 repeating is the 37 over 12. Yeah. Okay. On the diploma exam, when you guys eventually write the diploma exam, the people who write those questions, they will often find ways to disguise questions so that you can't really type it in your graphing calculator, because they'll give you variables. I'm going to try to make some questions similar so you guys can see what that'll be like over the next couple of years. Because if the question was just purely find me the vertex, anybody who knows how to use a graphing calculator can find the vertex no problem. Right? But sometimes they'll find ways to disguise it so that like they'll give you an equation. Like for example, they might say, find the vertex of minus 3x squared plus 7x plus 8. And then your answer might be something like, where were we back here? A was this 1 right here. So the vertex would have been at 7 over 6, comma, whatever that is, minus A, blank, minus A. And they might write it using like a variable so that you can't actually just type it in your graphing calculator. So I'll show you some examples. It is rude. It really is. So, but this is really it's what separates dash 1 from dash 2, right? Anyone hopefully has the ability to just type stuff in their calculator and solve it. But if you're really good at what you're doing, you should be able to do it in your calculator and do it algebraically on paper. So that makes sense.
Dash 2 here come.
It'll be fine. Alright, so I think this is probably my last example here, then we'll call it a day.
That's the last one.
Let's try to solve this in a couple of different methods. First, let's try the quadratic formula, which honestly I'm actually just going to partially start and then say you guys can probably handle it. But then I'm also going to show you how to do it by completing the square as well. So, if f of x equals 3, it means that 3 equals minus 3x squared minus 18x plus 10. So if you wanted to solve this using the quadratic formula, you could go 0 equals minus 3x squared minus 18x plus 7 minus 18 plus minus 18 squared minus 4 minus 3 times 7 all over 2 times minus 3. You guys feel comfortable enough that you could use the quadratic formula to solve this if you needed to? Okay, let's talk about how to solve it by completing the square then. You know how I have this equation right here? I'm going to complete the square on it. So it was minus 3x squared minus 18x. Way the heck over there and turn it plus 7. Oh, remember how it was 3, but there was a 10 right there? I'm using the halfway down formula. That makes sense. Okay, so let's try completing the square. Minus 3 and minus 18, I made this one nicely on purpose, because you can factor in minus 3, right? So minus 3 leaves you with x squared plus 6x. Half of 6? Square?
Yeah.
Okay, so what we need to do now is make this x squared plus 6x plus 9. But I can't just randomly add a 9. I have to later subtract the 9, which has to actually by itself times by negative 3. And don't forget the 7 on the outside. Which leaves you with minus 3 x plus 3 all squared minus 27 plus 7 more, 34. Okay, I haven't been writing it this whole time, but this is equal to 0. Here's why vertex form is sometimes kind of useful. Let's say you have something in vertex form. It's actually fairly easy to solve for x. See how there's only one x variable sitting right here? To solve for that x variable, you just have to use your algebra skills. Okay, to solve for this x variable, here's what you do then. You'd minus 34 from both sides. So minus 34 would equal minus 3x plus 3 squared. Then you divide by minus 3. So 34 over 3 would equal x plus 3 squared. Then to get rid of the square root sign, or sorry, to get rid of the squared sign, square root. Okay, now when you square root, there's a plus or minus square root. So you have to do the plus and minus square root of 34 over 3. That equals x plus 3. And then we've done that, subtract 3 from both sides. So if you want to get what x is equal to, an alternate method to the quadratic formula would be to do that. I don't actually think it's better. I can see why the quadratic formula is preferred, but you can actually solve by completing the square.
Just go sign it.
Oh, you stick on. Did any of you guys finish the quadratic formula up here and actually get what x is equal to? So if you actually did the quadratic formula, it would be 18 plus the square root of 18 squared minus 4 minus 3, 7. Divide by minus 6. One of the answers I got was negative 6.3665 or something along those lines. Okay. If you did this completing the square method, it should actually work the same way. If you took the square root of 34 over 3 and then minus 3, oh, what's the other answer? If you took the negative square root of 34 over 3 and minus 3 more, is that the same answer? Yeah, it is now. So that wasn't as smooth as I wanted it to be. But do you guys see how completing the square is another valid way of being able to solve for x? I don't know why you do it, but you could. The reason why it's useful is that you have a single x by itself. In this format right here, you have x in 2 locations. Because of x being in 2 locations, you really can't isolate for x. But if you can get it into this format right here, you can isolate for x. All you have to do is subtract the other side, divide, square root, and subtract. It's not horrible. It's not great, but it's not horrible. Okay, quick summary of the day. So here's why you guys get the extra lesson in quadratics. In addition to being able to be fluent with your graphing calculator, I need you guys to also possess the algebraic skills to find all of these properties if you didn't have a graphing calculator. So let's walk through them. If I want you to find a x-intercept, what sort of format would be useful to find an x-intercept? Have it be factored. If it's factored, that'll find you an x-intercept. Okay. Let's say you want a y-intercept. Standard form, look for the constant term. If you want to find a vertex, put it into vertex form. So ideally, you guys should now have the skills to be able to transfer between any of those formats. Okay. Converting into standard form usually just means you have to FOIL stuff out. Putting into factored form means you just need to factor stuff. Putting things into vertex form sucks, because you have to do the whole complete the square business. But if you can, it now means you have an algebraic tool in your toolbox to be able to solve for a vertex. Okay, so although, like I've been saying here, although you don't have to do it every single time probably on this course, please try it. It's worth your while if you have aspirations to go on to calculus, because you won't always get a graphing calculator. So it's worth it to practice the algebra. Okay, one last thought, and then you guys can probably take off here. Do you guys have skills journals nearby?
Oh no.
Yeah. So I'm gonna have you guys do some work at skills journals again. Do you have one nearby?
No.
Yeah.
Same one. Okay, I have a gift for you.
Oh, this is okay. So if you guys have a skills journal, here's some of the pages that you guys are gonna want to start putting some extra practice on. Can you find the one that says graphing linear functions, graphing quadratic functions, graphing polynomial functions? This is kind of the section we're looking for.
X to the 5.
Okay. So graphing linear functions, I really made for my grade 10s. because honestly that's mostly what they do, but it doesn't hurt for you guys to practice that once in a while. If you guys read the little preamble though, see how it says for each of the functions, sketch a graph and state the key characteristics. Right? So those would be things domain, range, intercepts, asymptotes when we get to them, axis of symmetry, all that sort of stuff. But I also write there, you could also attempt to determine the intercepts algebraically. You should be able to find almost all of the properties actually algebraically if you know how now. So one of the things I'm going to ask you to do tomorrow in the practice journals, we won't do a whole ton of them, but just as a couple, I'm going to ask you to graph these things. But I might also ask you to find me the properties without graphing. So for example, if you have a page in front of you, maybe say, look at graphing quadratic functions number 1. The equation is 2 bracket x plus 1 all squared minus 3. What is the domain of that function without graphing? What is the domain of that function without graphing?
X is now the range.
Good. What's the range of that function without graphing? Good job. Yeah, y would be greater than -3. What is the axis of symmetry?
1.
X equals -1. Good. Yeah. If I were to ask you then what the y-intercept is, you probably don't need to FOIL the whole thing. You can probably do most of it in your head. What really matters is when you FOIL out the x plus 1 by the other x plus 1, the last number is going to be 1, which will then times by 2 to give you a 2, which will then subtract 3. Your y-intercept is -1. You can often, once you know what you're doing, you can do almost all of this without a graphing calculator in terms of finding the properties. So that's what I'm going to challenge you guys for tomorrow. I'm not actually going to ask you to graph this, although you could. Right? If you just want more stuff to practice graphing, you could. I'm going to ask you guys to take some of these functions here, and I'm going to ask you to find the properties without graphing. Okay? So that's your challenge. Okay? Eventually, you guys can see that we're going to get to the pages afterwards, polynomials, and I mean, eventually you're going to have to find these properties of the power of 3, 4, 5.
Yay. Can't wait.
It's going to be a good time, guys. Alright. Do you guys have questions?
I'm so excited.
Just now? Yeah, totally. The key's up there. Okay. Tomorrow's a work day. Woo! We're gonna try a quiz on Wednesday. Okay. Put it up Thursday or Friday. This kind of is on the quiz, but I'm gonna put like one of them on there just so you know. So don't feel like this is really it. If you could do everything up until today, that's more or less what your quiz is on. Sound good?
I'm 23.
They have a library.
Oh, okay. We can do the graphic on that. I'll hold on to it for now in case someone else. Thank you. Okay. Yes, that's right.